All right, so hello, good evening to everyone. Welcome to our Institution of Global Professionals free webinar. Right, thank you so much for joining us in this wonderful evening. I am Sir Jason S. Yumang, a licensed professional teacher, currently teaching at Caduntete National High School from the beautiful country of the Philippines, and I will be your host for today. I am proud to be associated with IGP as a global member. I feel honored and privileged to host this webinar. It's my delight to welcome you all in this institution of Global Professional Free webinar. Again, I thank you all for joining us today in this marvelous evening, and it's my humble request and pleasure that you will all stay with us until the end. For I'm pretty sure you will have many takeaways and payoffs from this webinar. Each time, you can like, comment in our webinar, and please don't forget to tag, share, and mention your friends in the comment box. So let's watch together and learn together. We believe the power the power is gained by sharing knowledge and not hoarding it. So like every day, some new participants join with us on our free webinars. So I have a little concept about what an IGP is all about. Institution of Global Professionals, or IGP, serves student and community resource, providing a holistic social work and education to create a proficient generation. IGP is a leading online skill development institute with thousands of learners worldwide. We are able to share knowledge, useful to expand knowledge, boost confidence, to face any circumstance, and most importantly, to develop own skills. We are also interested with the international recognition. IGP also provides social works. We believe that it's not effective to increase one's skills just by acquiring formal education. So we provide effective training and consultation to generate proficient generation all over the world. IGP also organizes webinars, trainings, offline and online courses by the best and trained speakers, coaches from the entire world to create a best learning platform for you all. Our mission is also to empower people and provide each student a solid foundation of knowledge and skills to help them become a confident learner. And now we have successfully completed 270 webinars successfully. And we expect that you are getting benefited both in personal and professional life. And we wish you that you will remain with us throughout this journey. So before we begin this program, let me remind you once again, our lovely audience, to please share, tag, comment, and mention your friends in the comment box because your attachment encourage us to do better and provide our best services to you all. And now I am really excited to present to you our webinar number 271 for our topic, Pedagogical Analysis, Science and Mathematics Education. And our speakers for today are Sir Mark R. Maglake, and also we have Sir Michael R. Maglake. So let's start our program with IGP's mantra, feed your skill. Our first speaker is a Department of Education Secondary School Teacher 3, a professional at Mabalacat City College in the Philippines. Also, he is a researcher and innovator at the Department of Education. So, ladies and gentlemen, let's put our hands together as we welcome on the screen Sir Mark R. Maglake. So, sir, how are you doing today? You are muted, sir.
Hello, Sir Jay.
Yes, sir. How are you doing today, sir? Mark.
I'm doing good, sir. And my sincere thanks and gratitude to all of our, of course, our technical working group for the Institute of Global Professionals. Of course, to our audience tonight. um,
Mhm.
which are present listening to our webinar. This is free webinar, international webinar. And so we're going to embark with the expansion of the horizon, specifically knowledge. And so, therefore, tonight we are expecting some comprehensive discussions about how we relate philosophy to mathematics and science education. Thank you, sir.
All right. Okay, so I guess it's not just me who's really excited to witness the event for today, because like personally me I am a science teacher, so that's the reason why I'm really excited about this presentation for today. But before you start your presentation, sir, I just ask one question?
Yes, sir, Jay. My
Okay.
pleasure.
So yeah, like may we have a little bit of idea on what to expect on your topic, philosophy of education fit in today's world. So like, can you give us a heads up on what we're going to expect? Any ideas or like details on what we're going to expect on your presentation? Because yeah, we can't deny the fact that nowadays, we are facing, we are in the new normal, right? And then we are in the midst of the pandemic caused by the coronavirus disease, right? So I am kind of I'm a little curious about the philosophy of education that fits in our world today, right? So especially in the subjects science and mathematics, they are really useful, like even before, and especially nowadays, right? Because of the world of science, for example, we get um, to have this vaccination to combat against the COVID-19, right? So can you tell us a little bit more of what to expect regarding your topic or the discussion for this evening?
Yeah, just to give an overview of what we're going to talk about tonight. Of course, the topic is all about pedagogical analysis, mathematics, and science education. Specifically, we're going to tackle the philosophy fits in today's world. So, my task is to relate philosophy to mathematics. And on our second session, the other speaker will talk about the relevance of these classical philosophies to science education. And then later on, along with the question and answer portion, we're going to harmonize. You know, that's the beauty of this webinar. We're going to
Mm-hmm.
harmonize philosophy, mathematics, and science. But let me just give you an overview of this particular topic, because in the parlance of mathematics education, one of the most important concept that you have to understand as educators of mathematics uh, is the fact that many of the teaching practices and teaching strategies, or so-called pedagogies today, are all rooted
Mm-hmm.
in what we call philosophy of education. So right now we are facing pandemic. Yes, it's true that a lot of webinars are conducted specifically on online distance learning. We talk about the different modalities, the of course the modular distance learning, and but all of this stuff, as we expand the horizon, they are all rooted in this what we call philosophy. And tonight we're going to encompass the these philosophies on this is actually a review, because some of us teachers nowadays forgot to uh, understand that there are these philosophies that we can actually imbibe along with the educative process, the teaching and learning process. And so that is just the introduction of what I'm going to discuss tonight. But thank you for that question. I love the way you ask questions. Is this already a Q&A portion, Sir Jay? Thank you,
Not yet,
Sir
sir,
Jay.
but we're really excited. Well, I was really excited earlier. Then, my excitement actually added when I've heard, the some of the words you have stated regarding the things that we'll be expecting for your presentation. So, like, anyway, sir, if you are ready, okay, then the floor is yours now, and take it away, Sir Mark.
Thank you, Sir Jay. So my topic tonight is about pedagogical analysis in mathematics education, specifically the philosophy of education fit in today's world. So by the way, I am Professor Mark R. Maglake, and I am inclined to many institutions in the Philippines, but specifically my mother school is of course the High School, DepEd Tarlac Province, and this is an honor to speak with of course the global audience and having this particular global thinking. Uh, and so let me start, of course, by introducing myself, some of my inclinations to other institutions. I am also a part time professor at Mabalacat City College in the Philippines. I'm handling professional education subjects for graduates of 4-year non education courses. I am also a part time faculty member of Tarlac State University, College of Teacher Education, specifically for the Laboratory School for Grade 11 students. And I am also a researcher and innovator at the Department of Education, Division of Tarlac Province, a resource speaker and panelist to many research colloquium. Currently, I am studying Doctor of Philosophy major in Mathematics Education at the Nueva Ecija University of Science and Technology, Philippines. I graduated Master of Arts in Education major in Mathematics at Tarlac State University with a thesis titled Teaching Styles of Mathematics Teachers Correlation to Students' Academic Achievement. Then I graduated Bachelor of Secondary Education, major in Mathematics at Mabalacat City College. I graduated magna cum laude. Now, let me just begin with this some sort of acknowledgement before I formally start the presentation. I would like to acknowledge, of course, the overall technical working group, the Institute of Global Professionals, Dr. Kaushik Datta, Director and Founder of Institute of Global Professionals, Dr. Ronaldo A. Pozon, CESO 5, Schools Division Superintendent, Tarlac Province, Philippines, Augusto Ballesteros, Education Program Supervisor 1, Mathematics, Schools Division of Tarlac Province, Philippines, and of course, my principal, Dr. Ariel V. Calvo, Principal 2 of Dapdap High School, my head teacher, of course, Madam Clarinda D. Magtoto, Head Teacher 6 of the Senior High School Department, Dapdap High School, and of course, Dr. Redentor Tabamo, Head Teacher 3 of Benigno S. Aquino National High School, Philippines. And of course, my family, Dapdap High School, both the junior high school and the senior high school. Madam Marilyn Arcilia, the Dean of the Institute of Arts, Sciences, and Teacher Education, Mabalacat City College, Philippines. And of course, Dr. Jasper J. N. Mendoza, the Dean of the College of Teacher Education, Tarlac State University. What are the objectives that we're going to have tonight? Of course, we're going to define first what is philosophy. The second objective is we're going to identify the four major branches of philosophy, namely epistemology, metaphysics, axiology, and logic. And then number three of our objective is to relate the four major branches of philosophy in mathematics education and enumerate the different philosophies of education and their implications to mathematics education. Of course, we have this existentialism, essentialism, perennialism, progressivism, constructivism, and behaviorism. These are known to be the isms of education. Okay? So, yeah, let's start our presentation tonight. So, this is the main idea of my talk, philosophy of education fit in today's world. A lot of us today are saying that these are old-fashioned philosophies that we don't need to consider, especially when we are now in the field of teaching. But it's very important. That is the reason why we conducted this webinar so that we can remind ourselves within the bounds of knowing these different philosophies will lead us and will guide us along with our teaching practices. Okay, and then we're going to answer the question: Uh, does all of this philosophy fit in today's world, specifically in mathematics education? And then I'd like to believe that a great teacher is a teacher of wisdom. This is based from my experience, based from what I have learned in the educative process. It's very important that a teacher must be a teacher of wisdom. In whatever endeavor that you're going to come up inside the classroom, it's very important that as a teacher, you are a teacher of wisdom. And let's talk about the nature of philosophy. For the nature of philosophy, one cannot simply divorce himself from philosophy. The moment someone starts asking anything about his environment, himself, his society, that is what we call philosophy. And so, therefore, you are philosophizing, isn't it? And aside from that, it is in the nature of philosophy that a person inquires for the meaning of himself and the world around him. According to Taoist perspective, philosophy is it's more that human being is one with the universe, the cosmos. Everything that happens in the universe will ultimately affect man, and everything that man does will affect the universe. It is a holistic view that sees the world as interconnected, interdependent, and integrated in so many different ways. That's according to Dennis Quinich. It inquires about entire breadth of reality and gives a purely rational explanation of its totality. So, what's the purpose of knowing philosophy? It's a framework of all knowledge, branches or areas. Whatever you are doing within the teaching and learning process, they are rooted in what we call philosophy. This is what we call the framework of all knowledge, invaluable for acquiring the skill of critical thinking that is mark of a well-educated person, way of integrating knowledge. According to Pythagoras, the one who invented the term philosophy, there are three types of man. One is a lover of pleasure, second is a lover of success, and the third one, which is very important, is a lover of wisdom. Okay? And so the question tonight is what is love of wisdom? Okay? Love of wisdom is it gives the impression of someone who is seeking wisdom, not one who has found it. Desire to know what you really want to know. It's very important that as teachers, uh, we are being reminded that we have to provide students with not just with the brain, not just uh, a smart or educated person, but a person that is holistic. When we talk about holistic, it's not just about the head. Okay, we're talking about the heart and the hand. That's my formula, by the way. Uh, in my class at Babalacat City College, that is my formula. I don't know if that is reflected to books, but for me, I'd like to believe that we have 4H. No, we have holistic education that is equal to uh, the head plus the heart plus the hand. That is what the holistic education is all about. And so that is inclined to what we call wisdom. The question tonight is whenever we are teaching, whenever we employ our teaching strategy, uh, of course, are the learners learn those particular concepts the way they should be? How about the question of uh, they develop this what we call wisdom? While it's true that a great teacher is a teacher of wisdom, it's also the same reflection that our students must also imbibe this kind of wisdom. And that is very important. Okay? And philosophy, as a science of all things, Philosophy is the queen of all sciences, actually. We can relate philosophy to psychology, to linguistics, artificial intelligence, neuroscience, anthropology, and a lot more. Okay? Because as what I have mentioned a while ago, all of these branches of knowledge, as we expand the horizon, they are all interconnected to what we call philosophy. Okay? Philosophy as natural light of reason. And it's very important that whenever we teach inside the classroom, of course, we allow our students to develop this kind of reasoning. Okay? They become independent learners. You know, in psychology, we can relate psychology to philosophy. There is this what we call zone of proximal development, wherein we teachers, we assist our learners. We facilitate learning inside the classroom, but at the end of the day, we want them to become independent. So there will be a moment or a spare of time within this particular process that our learners learn to discover their own potentials. And that is very important. Okay? We allow our learners to think logically. We want our learners to explain mathematical concepts, scientific concepts. And that's education in totality. Okay? We do not just control our students the way they should be. We have to let our students discover who they are as a person. We investigate using our natural capacity to think or simply human reason alone. Now, let's talk about philosophy as a study of all things. Okay? Because as what I have mentioned a while ago, philosophy is the love of wisdom. Therefore, it is congruent to say that whatever endeavor our students will come up inside the classroom, it is rooted to what we call philosophy, which is the study of all things. Okay? And again, as what I have mentioned a while ago, it's very important that our students develop this kind of wisdom. Okay? And the diverse nature, this is also another one of my statements. Okay, that the diverse nature, scope, and importance of philosophy have much to offer in developing a relevant mathematics curriculum. Thus, teachers, administrators, and supervisors need to study significant educational philosophies to determine related implications within the framework of teaching and learning situations or processes. Okay, I know we have different teaching strategies, method, techniques that we are employing inside the classroom. Sometimes they call it eclectic method or strategies. But at the end of the day, do we know what is our philosophy in teaching? That's very important. Uh, as we end this session tonight, we're going to answer that question. What is your philosophy? It's not just about mathematics or science, but if let's say you are teaching other subjects, you need to ask yourself, what is my philosophy in teaching, in educating? Okay, we are more than teachers, right? We are educators. Okay, and so there are numerous schools of thought in the philosophy of teaching and learning, which provides direction in the selection of objectives, learning activities, and appraisal techniques. Mathematics teachers need to be well versed. Let me just give emphasis on that to our dear mathematics teachers. Mathematics teachers need to be well versed in the educational philosophy arena to assist students or pupils to achieve optimum in intellectual, social, emotional, physical growth, and spiritual aspect of their well-being. That's very important. Yes, it's true. We have the curriculum. We have the curriculum designers. In the Philippines, we have this most essential learning competencies. Okay? And along with this curriculum guide, whatever it is, are we achieving this kind of optimum level when it comes to intellectual, social, emotional, physical growth, and spiritual aspect of our students? Okay, now that we are facing pandemic, can you develop all of this well-being of our learners fully? That's the question. Okay, so we have to review tonight the different philosophies so that we can establish what is the direction of our teaching pedagogy. The branches of philosophy, there are four major branches of philosophy. We have the epistemology, we have the metaphysics, we have the axiology, and we have also the logic. When we talk about epistemology, for me, it's just more of the knowledge. Okay? When we talk about metaphysics, you are dealing with the reality. When we are talking about axiology as a branch of philosophy, it's all about values. Okay? When we're talking about logic, it's reasoning. Okay? And let's start with epistemology as part of psychology. So the efforts in order to show that we do in fact have knowledge are useless. Okay? We must take note of this. We must instead study the ways in which we form beliefs. Study the psychological processes that take us from sensory stimulations to beliefs about the world. Sensory stimulation is the activation of one or more of the senses, including taste, smell, vision, hearing, and touch. Knowledge is a natural phenomenon, the outcome of the natural processes whereby sensory stimulation leads to theories about the world. Okay? And so these are the inputs. We have this what we call sensory stimulation, and the outputs are said to be beliefs. And so the scientist does the same. She or he has empirical observations and forms a theory. Okay, that is why the role of a teacher is very important inside the classroom. We have this what we call pseudo learning or false uh, learning. Okay, and that's a mortal sin inside the classroom wherein we teach a wrong concept to our students, and that is very critical. Okay, as teachers, uh, as we discussed in the teaching profession, within the subject of the teaching profession, it's very important that aside from the personal qualification, as teachers we imbibe this what we call professional qualifications. And one of the highlight of professional qualification is the mastery of the subject matter. So it is very important that as mathematics teachers, we master the concept itself. We master the topic because it's very critical that there is an error upon our delivery of the instruction. Okay? And so these sensory stimulations will be our input, and then later on that will become a part of their belief system. Okay? And so our learners are being indulged to what we call environment. Okay, so it's very critical. More than just the knowledge that we are discussing here, is the sensory stimulations that we do inside the classroom. Okay, this is the activation of one or more of the senses, including taste, smell, vision, hearing, and touch. Okay, there are these types of epistemology that I would like to present tonight. We have the foundationalism. All knowledge is built on the basis of a few axioms or statements that cannot be doubted. Okay, for example, geometry is based on a few axioms like 2 points determine a line, and parallel lines never intersect. On the basis of these statements, geometricians can derive all sorts of mathematical truths. Now, regarding this type of epistemology, which is foundationalism, okay, I would like to emphasize that there are this what we call pros and cons. For pros, we can say that foundationalism is extremely precise. Okay, and it draws clear line between what is knowledge and what is not. As long as the actions are true, we can be 100% sure of our knowledge. Okay, on the other hand, we have these cons. Okay, you have to have a lot of confidence in your actions. If just one action turns out to be false, then all of your knowledge can come crashing. This is a small risk in abstract fields like geometry. But when you start talking about the real world, things get messy in a hurry. And so it gets very difficult to create reliable actions or foundationalism. And we know that knowledge is said to be what? Not absolute. Okay? We are avalanching down to what we call change. And so knowledge is very dynamic. So that is one of the cons of foundationalism. Okay, foundationalism is more of the foundational concepts that we have learned before. Okay, and that cannot be doubted. But then again, for instance, there is this what we call more modern geometry that proves that uh, it is possible that parallel lines can intersect. One concrete example is the globe. Okay, so how can the foundationalism people respond to this query? Okay, so what if there are some new trends in mathematics? How would the foundationalist people react on this? Okay, next one is, aside from foundationalism, is what we call coherentism. So knowledge is true as long as it isn't self-contradictory. You can believe whatever you want, and as long as it's consistent with itself, it counts as knowledge. Okay? And here, what are the pros and what are the cons? Okay? For the coherentism, it's very flexible, right? And because it isn't based on actions, because when we're talking about actions, that is what we call foundationalism. But here, you don't have to be completely welded to any particular claims if something turns out to be false. You can just throw it out, and the rest of your knowledge is still sound. How about the cons of coherentism? Coherentism makes it hard to judge other people's views as false. For example, what if someone said that unicorns are real and they live on Mars? Okay, this is a pretty ridiculous claim, right? Okay, and but it's not a self contradiction. And on the basis of coherentism, it would be very difficult to disprove. So coherentism might be too flexible. Okay, the next one is, we're talking about knowledge here. Okay, we have the foundationalism, we have the coherentism. The next one is what we call pragmatism. For pragmatist people, if it works, it's true. Ideas are just tools that human beings use to get by in a world that will never fully understand. If the tools work well for their purpose and help us live good lives, then they are true. If not, they are said to be false. Okay, what are the pros and cons of pragmatism? Pros, in such a way that it avoids the problems of both foundationalism and coherentism. Also, pragmatists realize that human beings have limits and our knowledge is always changing. In terms of cons, for pragmatism, it's hard, isn't it? It's true. It's hard to define what works. What is the gauge that you can say that this one works so that you can consider it as knowledge? So these are the kinds of knowledge that we are emphasizing in philosophy, in whatever branches of knowledge, not just in mathematics or science, but in all branches of knowledge. We have what we call foundationalism, we have coherentism, and pragmatism. Okay? And so I would like to ask all of you, what is now, uh, okay, this is the, this is where we're going to gauge whether, what is your type of epistemology. If you are foundationalist, if you are more of the coherentism, or if you are a pragmatist, on how you particularly define the meaning of mathematics. Now, I would like to request our global audience to please go to menti.com, okay? And then here's the voting code. We have 22, 888, and 18. I want you to define, okay, what is mathematics. Okay, go to the www.menti.com and use the code flash in our screen. Okay, and then I want you to type in what is your definition of mathematics. The code is given in our platform. I would like to request our global participants to type in your answers to www.menti.com and use the code flash in our screen. So we have 2288818. So here we go. We have this particular definitions. So it highlights that the majority of our participants in the platform defines mathematics as more of numbers. We have also participants who mentioned that math is around us. It's more of solving, it's more of logic. What else? It's more of equations. A profound definition is given here, an exact science, a language of science. Absolute. Of course, we have formulas. What else? It's more of analysis, which is correct, right? It's systematic. There is organization upon our solutions. It is the study of patterns. Okay, that's one of the precise answers here. Okay, study of patterns. But all of your answers are correct. Okay, so majority of our participants uh, give this particular definition as mathematics is more of numbers. It's more of solving. It's more of logic. What else? A school of subjects. So we have that kind of definition. We have, so aside from science that is more of facts, we can also say that mathematics is formulated with facts. Okay, we're talking about shapes, that is under geometry. Numbers and analysis, that's correct. It is a way of life. Oh, that's a morbid thought. That's a morbid thought. It's a way of life. Okay. It's more of a number theory. Number theory is one of the subject in college, which is interesting. Okay. And what else? Deep analysis. Okay. For linear programming in higher mathematics, that's one of the subjects. We have the linear programming. We also have differential equations for calculus. Okay, calculus may be differential or integral, but the higher type of calculus, which is considered to be as an advanced, is what we call the differential equations. Okay, combinations of numbers, that is for probability. Okay, it talks about accuracy. It talks about complex. It is complex. In fact, in our doctorate class, we have this complex analysis. We have also this real analysis subjects. Okay. And then one definition that strikes me is it talks about life. Mathematics is life. Later on in my succeeding slide, you're going to embark with this particular definition, the mathematics of life. Okay. And then another definition here is real. Okay. We can also talk about quality, but majority of our participants, however, within their a spectrum of mind, I think they think about mathematics as more of quantity, But I love the idea that mathematics is not just about quantity but quality. Okay? So, thank you so much for your participation in this short activity. Let's go back to our presentation. Okay, let's talk about the definitions of mathematics. Okay, and we can relate it to philosophy. Okay, right now in the philosophy that we're discussing, we are on epistemology, okay, which we highlight the importance of knowledge. Okay, as teachers, we have to be competent. We are equipped with what we are teaching. Okay, that's very important. As professional teachers, we have to uh, master the subject matter because that's one of the criteria. Okay, some says that mathematics is the study of numbers and arithmetic operations, which is one of the definitions a while ago. I'm glad that you have mentioned this because it's true that it is the study of numbers and arithmetic operations. Okay? I'd like to introduce tonight, okay, this what we call modern mathematics, which is known as Vedic. Okay, this is the world's fastest mental math system, a system based on 16 sutras or word formulas, far more systematic, simplified, and unified than the conventional system. It eradicates math phobia and creates an interest towards the subject, builds and strengthens math concept. Uh, Many years, centuries, okay, we are dealing with traditional mathematics. But as we open, we have mentioned a while ago that knowledge is said to be not absolute because it keeps on changing. It's dynamic. Therefore, there are a lot of developments in the field of mathematics. Okay, and it's very important that we are open-minded to these changes. And one of this is this what we call Vedic Mathematics, which was introduced to us. Okay, this is the world's fastest mental mathematics system. Okay, so I would like to uh, give an example, some of the Vedic mathematics that we can actually tackle tonight. But there are a lot of Vedic mathematics, okay? But just to ignite, okay, the knowledge within our minds, allow me to share this particular type of Vedic math, okay? So we have this mystery of 11. I call this mystery of 11. So we have 43 times 11. Well, the conventional or the traditional way of solving this kind of problem is we use this column method, right? We are used to this during our elementary days. So 43 multiplied by 11. So 1 times 3, 3. 1 times 4, 4. 1 times 3 here, and then 4. Then we add, this is what we call the partial products, and then you add, you have 3, you have 7, and then you have 4. Okay, but here in the mystery of 11 for Vedic mathematicians, okay, we have 4 and then place a space in between. Okay, we have 4 and then 3 here, and then 4 plus 3, that is 7. That is the reason why our answer is 473. This is one of the example of Vedic mathematics. But I think some of our mathematics students are not used of this. No, and I'm really sad because in other countries, okay, they are now adapting to these changes in the progress or in the development of the curriculum of mathematics. It's very evident nowadays, specifically in the result of the PISA, okay, wherein Philippines, not just Philippines, but some of the countries, okay, rank at the bottom. Okay, why? Because the curriculum established in a, sorry to say, but I will be honest about this. because the curriculum is very highly traditional when it comes to these concepts. So the curriculum is there, but we have to imbibe this kind of changes, this kind of adaptation, the manner we teach. And so we have to be open-minded, no, as we go along with these practices inside the classroom. So we can adapt this what we call Vedic mathematics in order to improve the performance of our learners. Okay? Next, how about 25 times 11? Okay, so just give space in between. So 2 plus 5 is 7. So the answer is 275. Okay, how about 83 times 11? Okay, so we have here uh, space. Okay, and then we have here 11, then 8 plus 1. So the result is 913. Okay, so that is what we call Vedic mathematics. Okay, let's have more examples for this. Okay, for our global audience, how about this one? 281 multiplied by 11. Okay, how can you solve this one using the Vedic mathematics? Okay, you have 2 here, and then 1, and then what is the next process? 1 plus 8. Okay, look at these 3-digit numbers, 2, 8, and 1. And then 1 plus 8, 1 plus 8 is said to be 9. So you're going to put 9 here. And then the next one is 8 plus 2. 8 plus 2 is said to be 10. Okay, so you're going to have 0 here and then add 1 here. And so our answer is said to be 3091. Okay, that's another way of, the beauty of Vedic mathematics is it allows our learners to think outside the box. Okay, that's very important. We allow our students to discover and to explore different solutions. Okay, how about this one? 574 multiplied by 11. Same principle is applied. So we have 5 here, and then we have 4 here, and then 4 plus 7 is said to be 11. Okay, next. 7 plus 5 is said to be 12 plus 1, that is said to be 13. Okay? And then plus 1 here. And so our final answer would be what? 6,314. That is what we call Vedic mathematics. How about this one? Let us try more. Let's make it more exciting. Okay, if we have said to be 12,000 12,574 multiplied by 11. So we have 1 here and then 4. So you have to copy the first and the last digit. So you have 4 here. Okay, the next step is 4 plus 7. 4 plus 7 is said to be 11. Okay, and then carry 1 here. And then 7 plus 5 is said to be 12 plus 1, that is 13. Carry 1 here. You're going to add that. So that is said to be 5 plus 2, that is 7, plus 1, that is said to be 8. And then 2 plus 1 is said to be 3. That's the reason why our final answer is 138,314. Please check, no, using your calculator. Okay, that's one way of solving this particular problem. Okay, let's make it more, okay, exciting. How about if we have 789,843 multiplied by 11? Okay, so we have to copy 7 and 3. So we have 7 and 3 here. And then 3 plus 4 is said to be what? 7. And then 4 plus 8 is said to be 12. Carry 1 here. And then 8 plus 9 is said to be 17. Plus 1, that is 18. Okay. Plus 1 here. And then 8 plus 9 is said to be 17 plus 1, that is 18. Carry 1. Okay. You have 16. Okay. Carry 1. That's the reason why our answer is said to be 8. We have 8 here, and then 6, 8, 8, and then 2, 7, 3. So you have 8,688,273. Okay. And then we also have this what we call two-digit. For Vedic Mathematics, we also have the two-digit fast multiplication. Okay, so we have this kind of dots. So we can dots are the digit lines symbolize what you have to multiply. So if you have this one, that's the first arrow, and then you have here another 4 dots. Okay. It talks about cross multiplication. Then we have also here this arrow. Okay. So the movement is said to be from right to left. Okay, the movement of the multiplication that we're going to have is said to be from right to left. For example, let's have an example here. We have 31 multiplied by 22. So when we apply the Vedic mathematics here, we start here, okay, and so this is said to be 2 times 1, that is 2, and then do the cross multiplication here. So you have 3 times 2, that is 6, and then 2 times 1. Okay, so you have here 3 multiplied by 2 plus 2 multiplied by 1, that is said to be 6 plus 2, that is 8. So you have 8 here, and then 3 times 2 is said to be 6. That's the reason why you have 682 as your product. Okay, so you just have to follow this format. Okay, next, for instance, you have said to be 56 multiplied by 41. So this is said to be 6. So you start here, and then the cross multiplication. So you have 5 times 1, that is 5, plus 4 times 6, that is said to be what? 24. Okay, plus 5, that is said to be 29. Okay, and then carry 2. So 5 times 4 is 20 plus 2. So you have 22. Our product is said to be 2,296. As simple as that. Okay, this is one way of solving this kind of multiplication problems. Okay, how about the base method? I don't know if you are familiar with the base method. There is this what we call base method in Vedic mathematics, wherein uh, we have to consider that in multiplying numbers, they are said to be close to the power of 10. So you have 10, 100, 1000. So you have 10 base method, okay? 10, 100, 1000, okay? And you have to consider if it is said to be more than, is it more than or is it less than? For instance, if you have 99 multiplied by 97. Okay, so we're going to consider that it is under less than. Okay, so you have less than 100 here. So as you subtract, that is said to be 1. Okay, how about 100 minus 97? That is said to be 3. That's why you have 3 here. And then you're going to subtract. Either way, you will have said to be 96. 99 minus 3 is said to be 96. 97 minus 1 is also 96. And then you have to multiply this one. 1 times 3 is said to be 3. That's the reason why our answer is 9,603. Okay, let's have another example. If we have 98 multiplied by 97, okay, is it more than or less than? Less than. Okay, 100 minus 98 is said to be 2. 100 minus 97 is said to be 3. And so, as you subtract it, 98 minus 3, that is said to be 95. And then 2 times 3 is said to be 6. So I want you to check this one and verify using your calculator. It is 9,506. So ladies and gentlemen, this is what we call Vedic mathematics. Okay? You want more? Let's have another slide for this. Let me just add another slide. Okay, how about if we have more than? Okay, let's say we have 14. We have 14 multiplied by 12. Okay, so this is more than 10, right? The base of to the base of 10. Okay, so since it is more than, how many? Okay, so our response to this is said to be what? 4. Okay, so we have 4 excess. Okay, and then 12 here, so we have 2. So, and then this time you're going to add. So if it is more than, you're going to add. So 14 plus 2 is said to be 16. And then 2 times 4 is said to be 8. So our answer is 168. So if it is more than, the concept is said to be addition. If it is less than, the operation that you're going to have or implement is said to be subtraction. What else? Are you familiar with the mental squaring? This is also one of the techniques in mathematics from the Vedic method, wherein, for instance, we have 101. Let's say you have to multiply 101 to 101. Okay, what is the uh, excess? Okay, so you have here 1, right? And then here you have also 1. That is the excess. And then you're going to add, okay? So 101 plus 1 is said to be 102. Okay, you're going to add this one. That is said to be 102. And then you're going to multiply this one. This is said to be 1. So our answer is 10,201. Let's have another example. Let's say, for instance, for fast multiplication, let's say we have 102 multiplied by 102. So the excess is said to be 2, and then 102 plus 2, that is said to be 104. And then 2 times 2, that is said to be 4. So our answer is 10,404. How about 103? More examples, because the best way to explain this concept is said to be giving concrete examples. So 103 multiplied by 103, same concept is being applied. So here the excess is said to be 3. Here the excess is said to be 3. And so 103 plus 3 is said to be 106. And 3 times 3 is said to be 9. So our answer or product is said to be 10,609. As simple as that. Okay? So you have to teach your students this kind of technique. Okay? So that they will be able to understand that it's not the solutions in mathematics are not just linear in perspective. So it's diverse in nature. So we have solutions that are diverse, but the important thing in mathematics is that we do not violate rules. Okay, that's very important. Even if you have different ways or solutions, but the important thing is you have the same answer. Okay, we also have the mystery of 5. A while ago, I discussed the mystery of 11. We also have the mystery of 5. We have the mystery of 5. Okay, let's say for instance you're going to multiply 25 to 25. So for traditional way, you know the steps. But for Vedic mathematics, it's automatic that 5 times 5 is said to be 25. And then 2 times 2 is said to be 4 plus 2, that is 625. Again, 25 here is fixed. And then 2 times 2 is said to be 4 plus 2 is 6. So that's why you have 625. How about your teacher asks you to multiply 35 times 35 on the spot? 5 times 5 is 25, that is fixed. 3 times 3 is 9 plus 3, that is 12. Your answer is 1,225. 95 times 95 on the spot without using calculator. 5 times 5 is 25. 9 times 9 is 81 plus 9, that is 90. So your answer is 9,025. How about when you are multiplying an even number by 5? Even number multiply by 5. So let's say your teacher asks you to multiply 28 times 5. So the solution here is when you are multiplying an even number to 5, the last digit is always 0. Okay? Take note of that. The last digit is always 0. And then, take a look at 28. So 28 divided by 2, you just have to divide 28 by 2. That is said to be what? 14. So our answer is 140. Did you get it? Another example. How about 118 multiplied by 5 on the spot? So you know that the last digit is 0. 118 divided by 2 is 59. So our answer is 590. How about for bigger digits? We have 2,500 multiplied by 5 on the spot. The teacher asks you to multiply. What are you going to do? So the last digit is always 0. And so 2,500 divided by 2, that is said to be 1,250. So our answer is said to be 12,500. That's the That's the beauty of Vedic mathematics. It allows us to explore solutions at its finest. Okay? And Sir Mark, what if we're going to multiply instead of even number, we have odd numbers multiplied by 5? If we have odd numbers multiply by 5, I hope the global participants are, of course, solving as well at the convenience of their home. You can have a piece of paper and then join me as we do Vedic mathematics. Okay. So how about odd number multiplied by 5? Okay. For instance, we have odd number 17 multiplied by 5. What is the technique? Okay. The first technique here is you're going to subtract 17 by 1. That is said to be 16, right? And then divide it by 2, that is said to be 8. And then that instead of 0 as the last digit, here, when you are multiplying an odd number to 5, it's always 5 as the last digit. So you have 85. Okay, next. If we have 19 times 5, so again, 19 minus 1 is said to be 18 divided by 2. That is said to be 95. Okay, how about 273 multiplied by 5? You know that the last digit is 5. 272 divided by 2, that is said to be 136. So our answer is said to be 1,365. Okay, let's have more mental tricks. Okay, for addition, for the column method, we know this. That's the traditional method. But let me just introduce something new tonight. Okay. If we have 37 plus 68, this is a simple addition, by the way. Okay. But sometimes the spectrum of the brain, the way the brain solve this, it's kind of confusing in the traditional way. But as we use the Vedic mathematics, okay, how are we going to implement it using the Vedic mathematics? So here, we have said to be 37. So we copy 37 here, plus get the excess of 68, which is 8. Right? So 37 plus 8 is said to be 45, right? And then add the whole number, that is 60. Okay, so 45 plus 60 is said to be 105 because the brain works easily when it is what? Whole numbers. Okay, so how about 49 plus 25? Again, copy 49 and get the excess of 25, that is 5. So that is said to be 54. And then the remaining 20, that is said to be 74. Okay, how about in subtraction? In subtraction, let's say for instance, we have 82 minus 14. So we have 82 minus 4. That is said to be 78. Okay, 78 minus 10 is said to be 68. Okay, how about 55 minus 39? So 55 minus 9, that is said to be 46. Then 46 minus 30 is said to be 16. Okay, so that's how we do addition and subtraction. Okay, how about if your teacher on the spot, okay, wanted you to, let's say, let me just add another slide here. Okay, let's say for instance, your teacher wants you to get the square of these digits. For instance, 200 204 squared. 204 squared means you're going to multiply 204 twice. Okay? So here, what are we going to do? For Vedic mathematicians, okay, we have this kind of technique wherein we have three lines here. And then the first way is, of course, you have to square the first term. The second line, it is 2ab. And then the third line is b squared. Okay? And then you're going to multiply, of course, this 2 is said to be, this is your a and this is your b. So the two digits are said to be your b, and the first digit here is said to be your a. Okay? And then square 4, that is said to be 16. Okay, and then 2ab, so you're going to multiply it. Okay, and so this is 2 times 2 times 4, that is said to be 16. So you have 16 here. And then your a, you have to square your a squared. So that is 2 times 2, that is said to be 4. So your answer to this particular problem is said to be 41616. So this is said to be 41,616. Okay, that's how we solve for it. Okay, and then we also have addition of, let's say, addition of fractions. For traditional solving, we have the, of course, we get the LCD, the least common denominator. That is the traditional way of doing it. But let me just introduce something here for Vedic mathematics. The trick is, for instance, you're going to add 1/4 plus 2/3 here. So this is, you're going to have cross multiplication here. So 1 times 3 is said to be 3. 4 times 2 is said to be 8. And then you have to multiply the denominator. So 4 times 3 is said to be 12. And so 3 plus 8 is said to be 11 over 12. That's the answer. Okay? If you have 1/2 added to 3/4, that is said to be what? So you have 4 here plus 6 over 8. That is 10 over 8. So for the lowest term, you have 5 over 4, or 1 and 1/4. Okay. How about in subtraction? Same principle is applied here. So if you have 3/4 minus 1/3 is equal to 9 minus 4 over 12 is equal to 5 over 12. Okay, by just doing the cross multiplication and multiplying the denominators, you can have the answer. That's another what we call Vedic mathematics trick. Okay. Okay, let's continue our presentation. Mathematics is a tool or a collection of skills that help us answer question of how many or how much. Okay, it is a science of logical reasoning, drawing conclusions from assumed premises or strategic reasoning. A while ago in our Mentimeter, there are these responses that talks about logic. Okay, but in the definition of mathematics, specifically for modern mathematics, okay, we have logical reasoning, we have drawing conclusions from assumed premises or strategic reasoning. That is why in mathematics, it's very important that we allow our learners to prove or to derive a certain formula. Okay? So let us review elementary mathematics here. Okay? So what comes to your mind, no? When you come across this particular property, wherein according to the exponent rule, it states that when a non-zero number is raised to the power of zero, it equals 1. But as a teacher, you need to understand that why is it that when a particular number or quantity is raised to zero, it's always 1? For instance, we have 2 raised to 0, it's always 1. Whatever is the number, for instance, 1 million raised to 0, it's always 1. Okay? If you have this one, billions, trillions, in as much as they are raised to 0, the answer is always 1. So the question now is, why? That's the question of some of our learners. Do we address that questions? Okay? So it's very important that we allow our students to prove, because that's one of the definition of mathematics a while ago. It's a science of logical reasoning, drawing conclusions from assumed premises or strategic reasoning. We allow our learners to prove the concepts they are learning inside the classroom, specifically under mathematics. Okay, how can you prove that? Okay, that when a certain number is raised to 0, it's always 1. Okay, let's have the proof of this. So if we have, let's say, 2 raised to 0, we're going to prove, let's say, for instance, we set the number as 2. 2 raised to 0 is said to be 1. Okay, what are we going to do? We need to prove this one, that 2 raised to 0 is always equivalent to 1. So the first step is, we have 64 over 2. You have 32 over 2 here. Just follow the pattern. We have 16 over 2 here. You have 8 over 2 here. You have 4 over 2 here. And then 2 over 2. Then divide this one. This is said to be 64 divided by 2 is 32. So here we have 16. Here we have 8. Here we have 4. Here we have 2. And 2 divided by 2 is said to be 1. Moving to the left side of the equation, okay, we have to transform the numerator and the denominator into an exponential form. So what is the exponential form of 64? So that is said to be 2 raised to 6 over 2 raised to 1. Following the pattern here, so we have, this is how we prove this one. Okay, 2 raised to 5 over 2 raised to 1. Here we have 2 raised to 4 over 2 raised to 1. Here we have 2 raised to 3 over 2 raised to 1. Here we have 2 raised to 2 over 2 raised to 1. And of course, here we have 2 raised to 1 over 2 raised to 1. And then the next step is, since we have now the same base, okay, for exponential rule, we're going to subtract. So you have 2 raised to 6 minus 1 here, following the pattern. Here we have 2 raised to 5 minus 1. Here, 4 minus 1, 3 minus 1, 2 minus 1, and 2 raised to 1 minus 1. And finally, of course, we have to simplify this one. So 2, 6 minus 1 is said to be 5. That's the reason why 2 raised to 5 is equivalent to 32. And then 5 minus 1 is said to be 4. 2 raised to 4 is equivalent to 16. Here, 2 raised to 3 is equivalent to 8. And then 3 minus 1 here is 2, which is equivalent to 4 here. Okay? And of course, here we have 2 raised to 1 and 1 minus 1. Take a look at this one. 2 raised to 1 minus 1 is 2 raised to 0. Therefore, we prove that 2 raised to 0 is said to be equal to 1. That's how we prove. And so it's very important that we allow our learners to prove the concepts that we are learning in mathematics. That's the reason why in my pre-calculus subject, I always allow my students to prove the concepts. And I was surprised that some of my students make their own formulas. Okay? So learning should not be linear in perspective. It should be diverse. It should encourage the creativity of our learners as they prove. How about this one, the mystery of 0 factorial? Even college students, when you ask them to prove this one, they are being challenged of this. How can you prove that 0 factorial is always equivalent to 1? Well, the only solution for this, or one solution of this is, of course, we make an equation out of it. So we have, let's say, n factorial is equal to n multiplied by n minus 1 factorial. So in order to prove this one, you're going to use this equation. So n factorial is equal to n multiplied by n minus 1 factorial. And then we allow n equal to 1. So as we substitute, okay, we have 1 factorial is equal to 1 multiplied by 1 minus 1 factorial. So we have 1 factorial is equal to 1 multiplied by 0 factorial. And so, what is 1 factorial? We go back to the principle here. 1 factorial is always equivalent to 1. So therefore, it is 1 is equal to 1 times 0. That is said to be 0 factorial. So for the symmetric property, we know that 0 factorial is equal to 1. So therefore, we prove that 0 factorial is always equal to 1. Okay, but there are other ways on how to prove these things. Okay, we just have to let our learners discover this. Okay, because let us not make our class in mathematics highly traditional. So we have to consider a lot of pedagogical ways on how to bridge the gap, especially to the learners that are said to be having difficulty in learning mathematics. Okay? And that's the reason why we need to empower this what we call remediation practices. Even if we are in the face of pandemic, remediation is very important. And how do you conduct remediation? Of course, by giving essential and relevant activities. Okay? But of course, let me just emphasize this, my dear global participants, that it's very significant, it's vital and fundamental that you are not just only focusing to the non-numerates. Okay? You're not just focusing on the non-numerates or the students that are in need of help, but you have to give also enrichment activities to students that are genius. Okay? So your instruction in mathematics should be equitable. You're not just focusing on the non-numerates, but you give enrichment activities to students that are excelling, okay, in your particular discussions. So it should be equitable. Okay. Next, let's have basic geometry here. For basic geometry, we're going to encompass this one, the Pythagorean theorem, the proof of Pythagorean theorem. Let me just add another slide. We are revisiting the curriculum, by the way. This is a free webinar for some of our curriculum designers are probably watching. So we are opening some important ways on how to bridge the gap, especially to our learners that are having difficulty in proving this particular concept in mathematics. How do we prove this one, the Pythagorean theorem? Of course, there are hundreds of ways, but geometrically, by graphical analysis or through visualization, we can prove this one. But the question is how? Of course, in order to prove this Pythagorean theorem, we have, of course, the c squared is equal to a squared plus b squared. You have to use a square. Okay. Assuming this is a square. Okay. So inscribe within a square is another square. So we have a square here. Okay. And then we're going to look into the different areas of the different figures. Okay. So we have A, B, A, B, A, B, A, B. Okay. So we have the different areas. What is the area of the smaller square? Remember, we have two squares here. Let's start with the area of the smaller square. What is the area of the smaller square? This one. So it's obvious, right? So we have C here. So the area of the smaller square is said to be C squared. Okay, well, how about the area of the bigger square? Take a look at the figure and try to analyze what is the area of the bigger square. So taking into consideration the sides, we have A and B here. So that is said to be A plus B squared. So this is, it yields to A squared plus 2AB plus B squared, right? That's the expansion of the binomial. What else? What is the other figure form when a square is inscribed to another square? Of course, we have right triangles. Okay, we have right triangles here. And so the question now is, what is the area of the four right triangles? That is said to be, let us review what is the area of the triangle. Area is equal to 1/2 multiplied by the base and the height. But in this case, our base and height are denoted by A and B, right? And so we have area is equal to 1/2 AB. But in this case, how many triangles form? So we have 4. So area is said to be 2AB. And then upon this analysis, we have to allow our learners to analyze the given figure and formulate their own equation. So if I'm going to ask you, what will be the equation? Uh, uh, of course, we have now the three areas. We have the area of the smaller square, we have the area of the bigger square, and the area of the four right triangles. And in this case, you have to allow your learners to analyze the given figure and come up with an equation. And so what will be our equation? Okay, so we can say that the area of the smaller square is equal to the area of the bigger square minus the area of the four right triangles. So we have, what is the area of the smaller square? So we have C squared here. What is the area of the bigger square? So you have A squared plus 2AB plus B squared minus 2AB. So C squared is equal, you have to cancel 2AB here. That's the reason why you have C squared is equal to A squared plus B squared. So we prove that the square of the hypotenuse is always equivalent to the sum of the squares of the legs. Okay, that's how we prove. Okay, through analysis. That's the reason why when we are teaching mathematics, we have to allow our student to think higher order. That's what we call higher order thinking skills. Or this is what we call metacognition, thinking beyond thinking. Okay. I think it's already time, but let me just browse some of the concepts, okay, that we can review so far in the curriculum of mathematics. So for the basic trigonometry, specifically for the trigonometric identities, this is one of the topics that is very difficult for the learners. Okay? And so trigonometry is a branch of mathematics that studies relationships between the sides and angles of triangles. Of course, for the fundamental functions, we have the sine, the cosine, and the tangent. For the inverse function, we have the cosecant, the secant, and the cotangent. We know this one, that the six trigonometric ratios, we have the SOHCAHTOA technique, the sine, the cosine, and the tangent. So these are the ratios. Okay, we know this. And so for this particular concept in trigonometry, we have these identities. These are equations that are true for right-angled triangles. So we have the tan-sin cos hexagon here. We have the sine, cos, cot, the cosecant here, the secant, and the tangent. And the center is said to be 1. So this is very helpful in solving identities. We have the reciprocal identities here, wherein the reciprocal identity of sine theta is said to be 1 over cosecant theta. The cosine theta, the reciprocal is said to be 1 over secant theta. And then tangent theta is 1 over cotangent theta. Then we also have the quotient identities here as a review. We have the tan theta is equal to sine divided by the cosine. Sine theta is cosine theta divided by cotangent theta. Okay, for Pythagorean identities, from the word itself, you're going to employ here the Pythagorean theorem. So when you add cosine squared theta plus sine squared theta, the result is always 1. It follows the other identities here. Okay, and so let's have this simple trigonometric expressions. I want you to simplify this one. So when you ask the learners to simplify this, how are you going to teach this one to your students? Okay. So let us just have number 1 here. Okay, so we have cosecant theta minus cosecant theta multiplied by cosine squared theta. Okay, and so we have here, what is the next step? Okay, you need to factor out. Okay, so you need to factor out that is cosecant theta multiplied by 1 minus cosine squared theta. Okay, and then cosecant theta multiplied, what is the value of 1 minus cosine squared theta? That is said to be sine squared theta. Okay, and so you have 1 over sine theta multiplied by sine squared theta. So this is, it yields to sine squared theta over sine theta. So our answer is said to be sine theta. So this is how we simplify this kind of trigonometric expression. How about the second one? It looks like difficult, but it's easy to simplify. So let me just show it to you. Okay, so if we have said to be sine theta plus cosine theta, which is squared, plus sine theta minus cosine theta squared. So if you do the expansion of this binomial, so you have sine squared theta plus 2 sine theta. You're going to expand this binomial. So this is 2 sine theta cosine theta, then square the last term, that is cosine squared theta. And then same is true with the other one. So this is said to be sine squared theta minus 2 sine theta cosine theta plus cosine squared theta. Okay? And so the result is we have sine squared theta plus cosine squared theta plus sine squared theta plus cosine squared theta. And upon looking the tans and cos hexagon, what is uh, sine squared theta plus cosine squared theta? That is equivalent to 1. So therefore, this is 1 plus 1. So our answer is said to be 2. Okay, so what is the thing that I want to emphasize? Why am I showing this to you? We have to reflect that the essence of mathematics is not to make simple things complicated, but to make complicated things simple. This is according to Stanley Gather. Again, the essence of mathematics is not to make simple things complicated, but to make complicated things simple. So I will no longer prove this one because it's already time. But let me just browse some of these slides. But I hope we can have another session, no, for the extension of these topics. No, I am just relating it to philosophy so that we can have some understanding. Okay, so in the epistemological perspective of philosophy, it's very important that we are equipped as mathematics teachers, not only to the foundational knowledge that we are used to before, but we have to open our doors to different methods, different ways, different techniques, because that's the time that we can improve the dismal performance of our learners. Okay, and so we can prove this one as what I mentioned a while ago. We can implement those techniques here in order to prove this. Okay, in statistics, I don't know if you will understand it. By the way, this is a picture of our the wedding uh, that we had last year with my wife. Okay, but the statement here is, "Hey baby, you must be p greater than 0.05 because I failed to reject you." That's the concept in statistics, in the hypothesis testing that we are indulged to, right? This is one of the topics in statistics wherein our students are having difficulty. Okay, but again, for statistics, it's very important that to understand God's thoughts, one must study statistics, the measure of His purpose. Okay, for instance, we have the chi-square test for independence here. So let me just browse them. It's very important that in teaching hypothesis testing, you have to present the procedures for conducting the chi-square test of independence. First, you have to define the null and alternative hypothesis. You have to state the alpha, calculate the degrees of freedom, state the decision rule, calculate test statistic, state results, and state conclusion. That's very important because some of the mathematics teachers do not have this kind of procedures. That is the reason why our learners are having difficulty grasping these particular concepts. Okay? And so we can also apply statistics to some of the issues nowadays, like abortion. Okay? So this is the sample application wherein we're going to check if the individual's opinion regarding abortion is independent of age at 5% level of significance. So here we have the observed values. So here are the steps. We have the null hypothesis and the alternative hypothesis here. Of course, this is subject for testing in statistics. And so we have the critical values here. And then we have to state the decision rule. If x squared is greater than the critical value, we're going to reject the null hypothesis. Then we have the, of course, the expected values. If you have the observed values here, you have the expected values. So here are the values. So let me just browse them. Okay. And then you can also use, as mathematics teachers, you can use SPSS. So as teachers, you have to understand that there are these tools that we can use or we can navigate so that we can adapt to the changes, no, in our pedagogical teaching. Okay, so we can use SPSS to discuss these particular concepts. Okay, the SPSS is known as the statistical package for social sciences. You can assign values and labels here, the nominal data, okay, the seniors, the teenagers, the pro-life, the pro-choice. Then you can also have here the use of the Microsoft Excel. Okay, here in this particular example, you can just type the formula to obtain the p-value. Okay, for the SPSS, we are pertaining to the p-value. Okay, so in order to get the chi-squared value, you just have to type in this one. Okay, so that you can have the values of this the chi-squared value. Okay, in mathematics, I would like to emphasize this one also, the discussion on exponential models. It's very important that we have to teach our students practical examples. For example, Emerson deposits 50,000 pesos in a savings account. The account pays 6% annual interest. If he makes no more deposits and no withdrawals, calculate his new balance after 10 years. So this is the initial amount, 50,000. So so we have here the said to be 1.06. Okay. So the interest represents a 6% rate of growth per year, so that the growth factor or the constant multiplied is 100% plus 6%. So that is equivalent to 1.06. So to find an equation that can be used to find a new balance after any number of years by considering the yearly calculation, so we have this one. So 50,000 multiplied by 1.06, it yields to 53,000. So after 4 years, we have 63,124. But the question is, after 10 years. So by just applying this exponential model, we can actually have 50,000 multiplied by 1.06 raised to 10. So it yields to 89,542.38. So the new balance is 89,542.38. So when an amount increases by constant percent, we have exponential growth. So as teachers, we have these models, okay, so that we can make it easier for our students to grasp these particular concepts. Okay, same is true with the concern about bacteria. Now we are facing pandemic, virus. So we have this bacteria. Okay, this is one of the problems in exponential modeling. So a bacteria grows at a rate of 25% each day. There are 500 bacteria today. How many will there be tomorrow, 1 week from now, 1 month from now? So you can actually solve this, okay, by using the exponential formula. That is y is equal to a raised to ab raised to x, where a is said to be 500 bacteria, okay, and then 1.25, okay, for b, okay, and for x is said to be 1, if x is said to be 1. So therefore, if you follow this particular formula, for letter A, the answer is said to be what? 625 bacterias tomorrow. Okay? 1 week from now, if you will continue the solving here, it yields to what? 2,384.19. Okay, that is approximately 2,384. Here, after 1 month from now, okay, how many bacteria do we have? We have 3,897 bacteria. Okay, 1 month from now. So we can actually do exponential modeling in mathematics. Okay, and aside from epistemology, we have this axiology. Okay, the integration of values in teaching the realms of mathematics. When we are teaching mathematics, do we integrate values? That's the question tonight. Do we integrate values in teaching the realms of mathematics? So for the mathematics of life, I love some of the definitions a while ago that mathematics is about life. And so it's true because life is too short to argue and fight. Count your blessings, value the people who love you and make the most of each day. And then the mathematician's patterns must be beautiful. Beauty is the first test. There is no permanent place in the world for ugly mathematics. That's according to Hardy. And so it's very important that we should understand that the very essence of our life here, that there is this what we call thanatological idea that all of us will die. And so it is inevitable. It is unavoidable that all of us will die. Whether you are genius, whether you are a mathematician, whether you are a scientist, all of us will die. Okay, but I'd like to emphasize that God is the greatest mathematician. For me, that's my uh, definition of mathematics. That God is the greatest mathematician. And as we go along with philosophy, aside from epistemology, aside from axiology, we have this metaphysical reality. According to the experimentalists, we can say that knowledge is tentative and not absolute. So permanent knowledge does not exist. So this world is about experience. So in order to say that a curriculum is in mathematics is said to be achieved, students must experience, okay, meaningful activities inside the classroom. Okay, whatever is the modality, whether it is online distance learning, whether it is modular distance learning, so we have to give meaningful experiences to our students, and because that is under metaphysical reality. Okay, and you can say that again, the definition of mathematics a while ago, there are patterns. Okay, we have these patterns, and so we are not inventing here. We are always discovering the beauty of this world. Mathematics is everywhere. Okay, that's why we have symmetry. So we have the starfish, we have the butterfly. These are the patterns in nature. Mathematics is everywhere. So we have the Leonardo da Vinci's Vitruvian Man. So it shows the proportion and symmetry of the human body. Fractals. In nature, we have fractals. Okay, the lightning bolt, the cauliflower is an example of fractal. Tessellation, we have the patterns that are formed by repeated cubes or tiles. We have the pineapple here, we have the sunflower, the turtle here. The spiral are shapes that wind in a gradually or tightening curve. So we have the nautilus shell, we have the bighorn ship, we have the snail. These are mathematics. the patterns. We have also foam. Foam is an object formed by trapping of gas in liquid or solid. So we have the bubbles here. Bubbles are said to be concepts in mathematics. Stripe, a long narrow band. So when I visited the uh, Subic Safari here in the Philippines, I have encountered this one, zebra. That's an example of stripe, okay, which is a concept in mathematics. So therefore, we can say universally that mathematics is everywhere. This is the reality. This is the metaphysical reality. Math is everywhere. So if you want to look into transversals, just look at the things around you. You can see mathematics, parabolic shape, conic sections, etc., etc. We have also the metaphysical behaviorism. All behavior is environmentally derived. So nothing could be farther from the truth that we are being shaped by our environment and cannot be explained by appeals to heredity, instincts, the unconscious human nature, or internal predispositions. We have also this, we can relate humanistic psychology to axiology, which is one of the branches of philosophy, wherein as mathematics teachers, we have to be humanist. Reality is subjective according to how it's perceived by the individual person. And we have to consider the fact that the self-concept of the individual is highly significant. Positive experiences as perceived by students individually. Okay, and then there is this what we call self-actualization. Okay, which is the part of each person as an ultimate relevant goal. Do you still remember this one? The Abraham Maslow's hierarchy of needs. So it recognizes that the hierarchy of needs that must be met before learning in the school setting and in life may take place. The human needs identified by Maslow, which must be met in general order of importance, include the following. So in teaching mathematics, not just in mathematics, but we have to consider this, that our learners have this learning needs, physiological needs, safety needs, love and belong, especially at the face of pandemic. Okay? Do we have this kind of appreciation to them? Okay? Um, Sometimes when we have this kind of appreciation, then we elicit and then we add the motivation to our learners, believe me or not. So that's very important when we compliment our students. So a person needs adequate food, rest, and shelter before security needs are identified and ultimately resolved. Once security needs are met, being loved, let me just emphasize that. Being loved and having feelings of belonging must be met, and so on. Okay? Then our pedagogy, our teaching strategy becomes effective. Okay? So I will no longer discuss this one. So we have also the cognitive psychology, wherein as we relate to philosophy, which is under logic, which is all about reasoning, there is this what we call human intelligence. We have the perception, we have the language, we have the thinking and problem solving, we have the memory, we have the attention. In my research before, it turned out that it's a negative correlation actually. Wherein if the teacher uses more of problem solving strategy, then the performance of the learners becomes it declines. Okay, that's a negative correlation. So therefore, one of the implication of my paper or my study is to, have these trainings, okay, for teachers on how to teach this particular worded problems, how to solve particular worded problems, so that our learners are guided properly. Okay? So it's very important as math teachers, we do not just emphasize more of the numerical concepts, but we have this application so that learners will eventually become lifelong learners because there are applications with the concepts that we are teaching in mathematics. Just like what I have discussed a while ago. The branches of philosophy, uh, actually, this is the last part of my presentation tonight. We have discussed the logic, the metaphysics, the epistemology, and axiology. Philosophy is a broad subject. But allow me to share to you tonight the last part of this presentation. Of course, we have the sub branches. We have the philosophy of education. So, in the philosophy of education, I will ask this question: what is your philosophical heritage? Okay, it's very important that as math teachers, you need to identify what is your philosophy. Okay, so we are here to a rich philosophical heritage from the different philosophies of great thinkers in the past. We have these philosophical questions: what is life? Who am I? Why am I here? What am I living for? What is reality? Is the universe clear? But as a teacher, let us translate those questions philosophically. Why do I teach math? What should I teach? How should I teach mathematics? What is the nature of the learner? How do learners learn? So these are philosophical questions that you need to answer. So we have this existentialism by Jean Paul Sartre and Soren Kierkegaard. Okay, existence precedes essence. Okay, so why teach helps students understand and appreciate themselves as unique individuals who accept complete responsibility for their thoughts, feelings, and actions. So when you are teaching as an existentialist teacher, you always value, okay, you appreciate our learners, their unique uh, potentials. Okay, that's very important as an existentialist. And so these are the thoughts of existentialism in today's current educational system. According to Morgan 2013, the existentialist demands the education of the whole person, not just the mind. That is why I have devised this 4H formula wherein I always say to my students that there is this holistic education wherein when you add, okay, head, heart, hand, you have this holistic education. And that is very important. It's not just about the mind, the heart, okay? It's also about the soul. That's why spiritual education is also important, okay? And so these are the manifestations that we do existentialism in our pedagogical activities. Okay, next is essentialism. We teach what is fundamental, what is necessary or required. Okay, I'm going to wrap up my discussion now. This is the last part. So essentialism is to acquire basic knowledge. This is for basic knowledge, skills, and values. The teacher is the fountain of knowledge, paragon of virtues. It's more of 4R, reading, writing, arithmetic, right conduct. And essentialism in today's current educational system, while it's true that essentialism is old-fashioned, according to Morgan 2013, okay, I think this is a good idea to implement while they are young. Okay, so when entering higher education, the student not blindsided by a teaching style they have never encountered. I think teaching the essential, again, let me just emphasize that. I think teaching the essential is important. Some students may not enjoy math, science, and history, but it is what it is. Okay? Needed to be culturally literate individual who is ready to function in the world after school. Next philosophy is the perennialism. These are the philosophies of education. Okay? The central aim of education should be to develop the power of thought, the reasoning, to develop the students' rational and moral powers. When you are teaching mathematics, okay, do you develop the reasoning of our students? That's why I have discussed a while ago proving, because it highlights the power of thought, okay, these rational and moral powers of our students. Okay, according to Aristotle, if we neglect the students' reasoning skills, we deprive them of the ability to use their higher faculties to control their passions and appetites. So, perennialism in today's current educational system, again, we emphasize HATS, higher order thinking skills. As we educate the rational person, we also cultivate their intellect. Okay, and then in the perennialist classroom, the wisdom of the past is very essential to understand the events of the present and will eventually guide us as we predict what will happen in the future. It is very timeless. Progressivism is another philosophy wherein as math teachers we are receptive to fresh ideas and concepts, okay, to develop learners into becoming enlightened and intelligent citizens of a democratic society. Education is life, not a preparation for life. That's according to Dewey. Okay, progressivism in today's current educational system, according to Morgan 2013. Okay, so our role as math teachers should be to help our students, okay, accomplish the different learning activities and to make sure that there is an understanding that what they are trying to learn is important. Okay, so we have to make our students understand the world around them to become problem solvers. Okay, teacher leads for growth and development of lifelong learners. Second to the last one is constructivism. This is one of the philosophies of education that I want to emphasize. We have the assimilation and the accommodation. Assimilation is absorbing new information and experience and incorporate them into pre-existing ideas or schema. We also have accommodation. Okay? We replace the old beliefs. And then students construct their own meaning. So we in mathematics education, we have to allow our students to construct their own meaning, their own solutions. Okay? In the constructivist classroom, the teacher provides students with data or experiences that allow them to hypothesize, predict, manipulate objects, pose questions, research, investigate, imagine, invent. That's why we have research projects. Okay? That's according to Padron 2021. So in mathematics, we also indulge our students to do uh, researches. This is under Education 4.0. I don't know if you are familiar with that, but we are now on Education 4.0 wherein we are doing a lot of researches for the improvement of our instruction and the curriculum. And then we have also behaviorism, which is the last one, according to John Watson, shaping of students' behavior by providing for a favorable environment. Okay, and so in today's current educational system, teachers ought to make the lesson as clear and interesting as possible to capture and hold the learner's attention. There is a positive reinforcement and appropriate incentives to eliminate negative ones. And so, what is your philosophy of education? That is the question tonight. It includes the following: the human person, the learner in particular, and the educated person. What is true and good and therefore must be taught? How a learner must be taught in order to come close to the truth. And so these are the examples of philosophy of education of a mathematics teacher. I believe that every child is an embodied spirit, is unique, and so comparing a child to other children has no bias. Philosophy of education of a mathematics teacher, I believe that there are unchanging values. Okay? So it is therefore no joke to become a teacher. Okay? It is therefore no joke to become a teacher. There are a lot of demands and much is expected from you as a teacher. Okay? Your influences on your students and on other people with whom you work and live are greater. But these influences depend greatly on your philosophy as a person and as a teacher. Thus, your philosophy of life and your philosophy of education serve as your window to the world and compass in the sea of life. As a mathematics teacher, you have to care, not to scare. Especially now that we are in the face of COVID-19 crisis. Care means to look straight in the eyes, gentle touch or pat on the back, acknowledgement. Scare, name calling, ignoring one's capacity, belittling students. We want our students to see the beauty within them. Okay? What matters most is how you see yourself. We have to make our students realize their potentials, their dreams, their aspirations. This is what we call self-actualization. That's according to Maslow a while ago. Teaching mathematics involves the following: choice, collaboration, communication, critical thinking, creativity. But don't forget this one that I am going to share with you. Among the C's, we have care. That is very important. And so we have this what we call inspired learners. We are the mirror of our students. When a teacher is inspired, therefore our students become inspired as well. And we have to produce lifelong learning. And lifelong learner means there is a reflective behavior, metacognitive skills, self-monitoring skills. And lastly, what are the two loves of Sir Mark Maglake in the educative process? Love of the content and love of the children. Love of the children means we are the second parents and loco parentis. So thanks for listening in my session. Uh, God bless all of you. Sir Jay, thank you so much for your time. I think we can now proceed on the next part of the
Yes,
session.
sir. All
Thank you.
right. Mm-hmm. Thank you so much, Sir Mark. Let's all give Sir Mark a virtual round of applause. Wow, that was really amazing. We're
Thank you
really
so much.
grateful to you, sir, for sharing your marvelous presentation today. So, like, to be honest, I personally learned a lot from your presentation today. So, the nature of philosophy, the holistic education, and just like what you have said earlier, it's not just about the heart, but we must also use our head as well as our hands. And also, I've learned about the philosophy as the study of all things, the branches of philosophy. And when you asked the question earlier, what comes first in your mind when you hear the word mathematics? Well, actually, for me, the words that are coming in my mind whenever I hear the word mathematics are the numbers, of course, analyzing, logical thinking, equations, and etc. And also the Vedic mathematics. I learned about this strategy. It isn't just useful for us teachers, but definitely for our learners to make their computations easier and more exciting. Right. So once again, thank you so much, Sir Mark, for sharing your knowledge with us. No doubt that our viewers learned so much from your techniques, interesting stories, beautiful insights about how significant philosophy is, and most importantly, the takeaway knowledge. So once again, thank you so much, sir, for sharing with us not just your knowledge, but also your valuable time with us. So thank you. Right. So I guess it's now time for us to move on and our next speaker.
Thank
So
you,
our
sir.
next speaker, yes sir, thank you so much, is also a Department of Education Secondary School Teacher 3, an accredited electronics assessor trainer, and also a professor at Mabalacat City College in the Philippines. So ladies and gentlemen, hold on to your seat as we welcome Sir Michael R. Maglake.
All right. Thank you, Sir Jay, for introducing me.
Mm-hmm. You're
I think
welcome, sir.
that was really comprehensive on the part of the first presenter. On my presentation, I will just give the salient points, wherein
Mm-hmm.
I'm going to show to the global audience the relevance of philosophy into science education, because there were already bulk amount of information that was explained thoroughly to us regarding the traditional philosophies. So we will
Yes,
just
I agree.
explain some of the basic philosophies regarding education, and at the same time on how we can integrate it in our science education. So allow me to share my PowerPoint presentation to all of you.
All right, sir. We are not going to prolong the agony of waiting anymore. So if you're ready, sir, Michael, then take it away.
Thank you, sir. right? So I hope you can now see my presentation. So tonight I'm going to discuss the relevance of philosophy to science education. So of course, before we start our discussion, I would like to thank, although it was mentioned already by the first presenter, I would like to express my gratitude to the technical working group of the IGP, especially to Dr. Kaushik Datta, the director and founder of Institute of Global Professionals. And I would like to express also my gratitude to our schools division superintendent of Tarlac Province, Philippines, no other than Dr. Ronaldo A. Pozon, to Dr. Conrado C. Domingo, our education program supervisor, and of course, our dearest principal in San Roque National High School, Dr. Amalia D. Lising, my head teacher 6, Rowena T. Manipon, and I would like to express my gratitude to Dr. Redentor Tabamo, the head teacher 3 of Benigno S. Aquino, and of course, the San Roque National High School family, both junior high school and senior high school. And aside from that, because we are also teaching in Mabalacat City College, I would like to thank Ma'am Marilyn Arcilia, the Dean of the Institute of Arts, Sciences, and Teacher Education. So just to give you my profile, I'm already 5 years in my teaching profession, 4 years in public school, and 1 year in private school. So I'm a graduate of BS Ed Biology, and I finished my master's degree at Bulacan State University with a degree of Master of Arts in Education, major in Biology. And I wrote the thesis, Sowing the Seeds of Environmental Care, Regreening the Municipality of Bombantarlac. And right now, I'm currently taking my Doctor of Philosophy in Science Education at Nueva Ecija University of Science and Technology. And as what mentioned by the moderator a while ago, I'm also an accredited competency assessor for some of the qualifications in TESDA like NC2 EPAS, NC2 Housekeeping, and NC3 Events Management. I'm also a National Tibet trainer in TESDA. And in our school in San Roque National High School, I'm handling biology, chemistry, physics, and even some subjects like earth science. And currently, my position is teacher 3 at San Roque National High School. And I'm also a part-time instructor at Mabalacat City College. I'm handling teaching science in the elementary grades and general biology. Now, allow me to enumerate the objectives of this presentation to define philosophy, to define science, and to define philosophy of science, and to know the different traditional school of philosophies, and to establish the relevance of philosophy to science education. So, of course, in my presentation, I will be the last presenter tonight. I will not solve a lot of things that will complicate your mind, but because that is said to be laborious, because that will take a lot of time. But let us go back on the theme of this presentation, that we need to establish the relevance of philosophy into science education. So I will not focus on the content, but I will focus on the relevance, because that is the central focus of this presentation. So, of course, there are terminologies that was mentioned a while ago, like philosophy. So, we need to answer this particular question. Is philosophy relevant to science education? So, after this presentation, we will go back to this particular question. Okay, so how do we define now philosophy? The first presenter said a lot of things about the word philosophy, but let us just recall some of the highlights of philosophy. It is the love of wisdom. Okay, so more than the content, we are said to be focused on how we can help our learners to fall in love with learning, because that is now the problem right now. We are in the COVID-19. There are many problems in our society, but still we need to encourage our learners to keep on moving, keep on learning. So, in consonance to that, philosophy is an activity people undertake when they seek to understand fundamental truths about themselves. Okay, the world in which they live and their relationship to the world and to each other. So, meaning to say, we are not only concerned on how our learners learn that particular concept in science, but they need to relate that concept into their surroundings. And they should know how to use that knowledge in order to improve the lives of the members of the society. Meaning to say, these learners that are said to be learning, scientific knowledge must be productive and effective in our society. So they are not liabilities, but we must produce assets in our society. What I mean to say, later in my presentation, you will discover that there are traditional philosophies who are said to be, which are considered to be fundamental in encouraging our learners to be aligned, especially in science. So I'm talking of students, uh, who love to be a scientist. So philosophy from Greek, by the way, of Latin philosophia, which means love of wisdom, the rational, abstract, and methodological consideration of reality as a whole, or fundamental dimensions of human existence and experience. So, philosophical inquiry is a central element in the intellectual history of many civilizations. So, we can see here that rational, abstract, and methodical consideration of reality as a whole, no, must be the focus, meaning to say our students should know how to rationalize until such time you will see your learner that they have this abstract thinking. All right. So the use of reason in understanding such things as the nature of the real world and the existence and the use and limits of knowledge and the principles of moral judgment. So this is now the essence of philosophy. Why do we need to relate philosophy into science education? So this is now the significance. Okay. So the study of philosophy enhances a person's problem-solving capacities, and that's the reason why we wanted to intertwine philosophy into science education. We want our learners, specifically science learners, to be problem solvers. Philosophy helps with critical thinking and reason. So, meaning to say, philosophy promotes critical thinking and logical reasoning for our science learners. Philosophy helps guide the research process, meaning to say, as what mentioned by the first presenter a while ago, we encourage our learners to be researchers. Especially, they would love to, engage into science investigatory projects, which are now partly being promoted by other schools. But we aim that all schools will, strengthen that kind of science investigatory projects. Okay, philosophy teaches persuasiveness. All right. So, meaning to say, through philosophy, we can encourage our learners to engage themselves into a science-related field. Philosophy teaches problem solving. All right. So, this, just like what I mentioned a while ago, that we are using philosophy in order to make learners, no, that are said to be problem solvers. Okay, so philosophy can be applied to every discipline. Philosophy forms a good foundation for a variety of careers, meaning to say philosophy can also be applied into other disciplines of life. Okay, philosophy helps you sort through your own beliefs, so you can use philosophy in order to verify or to check your thoughts, whether these thoughts are really helpful on your part. Okay, so as a science learner or a science teacher, okay, so you can use philosophy in order to validate your thinking. All right, so philosophy influences the world today. Okay, and philosophy can fuel change and progress. And we know, let's highlight that word change. There is no permanent on this earth except change. Everyone is said to be changing. The curriculum is changing. The curriculum is dynamic. So therefore, all of us science teachers or science educators must be dynamic in terms of our pedagogy. So look at this one. I think the first presenter already mentioned the branches of philosophy. But let me just add, because he did not mention the part wherein ethics and aesthetics are part of axiology. So there are four branches of philosophy. All right. So we have epistemology, which is more concerned of knowledge. Metaphysics is more of the reality. So we wanted our learners to recognize reality. So that's why we have a lot of experimentations in science. Ethics. So we want to teach that ethics is part of learning, meaning to say the students should know what is right and wrong. Okay, meaning to say they will not just do the experimentation or invent something, but rather they should think whether this product of their experimentation is helpful in the society. Okay, so another one is logic. Okay, this is branch, or this branch analyzes the concepts and parameters of a demonstration or description. Okay, so we want our learners to be logical in terms of their thinking. Okay, so meaning to say they will not just believe no what they hear, what they read, but rather they will verify whether this information is really accurate. Okay, so just like what I've said, ethics and aesthetics are said to be related from one another because they are said to be under axiology, which is concerned about the integration of values. Okay, so let us define what is science. So we know that science is defined as the systematized body of knowledge covering general truths as tested through scientific method. So we are using actually scientific method most of the time uh, when we are engaging into science. It is any system of knowledge that is concerned with physical world and its phenomena, and that entails unbiased observations and systematic experimentation. Let's highlight the word experimentation. So when we are using the word experimentation, that means to say that we have this abstract thinking, we have this reasoning. So we need to validate this reasoning or hypothesis, whether it is true or not, by conducting an experiment. So therefore, when we are talking of science, experimentation is inseparable with this branch of knowledge. So in general, science involves pursuit of knowledge, covering general truths or the operations of fundamental laws. So as you can see right now in our surroundings, science is really manifesting, right? Look at the vaccines that we are having right now. We are enjoying it. So all of these are products of science. So it was mentioned a while ago, the scientific method. Look at this one. We want our science learners to realize a problem. I think that is the first step, right? They need to realize the problem. They need to know the problem. So, because if you don't know the problem, how can you perform experimentation? How can you, make your hypothesis, and then research design, collection of data, data analysis, and interpretation of generalization. So, we are developing our science learners to identify or realize problems in our society so that we can render solutions. to this. Okay? Now, there is this what we call philosophy of science. The philosophy of science is a sub-branch of epistemology, and it is considered to be the branch of philosophy that studies the philosophical assumptions, foundations, and implications of science, including the natural sciences such as physics, chemistry, and biology, the social sciences such as psychology, history, and sociology, and sometimes, especially beginning about the second decade of the 20th century, the formal sciences such as logic, mathematics, set theory, and proof theory. So we know for a fact that when we talk of philosophy of science, it is inseparable with history of science. So we study a lot of scientists like Democritus, John Dalton, Albert Einstein. So all of these famous scientists are said to be important figures in the development or evolution of science. So when we study philosophy of science, you will see the pendulum of civilization. There is actually movement, right? So from Renaissance going to the modern civilization that we have right now. So we cannot land on this present time without recognizing the contribution of the past scientists. And that is what we are teaching with our students, to recognize who are the people behind this technology, behind this invention. You know, the problem right now with our education, people are enjoying the products of science without thinking who are the people behind. So part of philosophy of science is to recognize where this or to whom this knowledge came from, and how this knowledge was said to be developed by people in the past. So we are not only recognizing the knowledge, but we are also recognizing those people. Okay, so there is this educational philosophy, a philosophy about education that requires systematic critical thinking about educational practice. Teacher educational philosophy helps the educator interpret, find meaning, and direct the daily work of the classroom. So we are now talking of this philosophy that are said to be applicable in our teaching pedagogies. Okay, what philosophy is applicable in my science class? All right. So a while ago, I posted the question: what relevant philosophy can be applied in science education? Okay. So as you can see, there was this research, okay, that there is connection between philosophy of science education, history of science, and philosophy of education. So we know that in philosophy, we are dealing with critical inquiry, foundations, and creative theorizing. So that is the highlight of philosophy. Now, this philosophy that we know is said to be linked to philosophy of science education, wherein we have the role, okay? So roles of theoretical or practical reasoning. So we have this role of assessing learning theories, okay? And assess goals, science literacy, and we assess policy documents. And we also perform meta-analysis of the field. So we're talking of worldviews and culture. So that is the philosophy of science education. We are now assessing. We are now looking to our curriculum, whether this curriculum is still applicable for diverse learners. All right. So another one is philosophy intertwined with history of science. We know when we are talking of history of science, we're talking of the content, right? So, but we are linking philosophy to history of science. Okay, we are putting now value, okay, to the information, okay, the history of science, okay, and then there is this philosophy of education, which talks about the interests, ideologies, and educational questions. All right. So all of philosophy is really a broad subject. All right. We are not only talking of epistemology, metaphysics, logical reasoning, and axiology, but how can we uh, relate now philosophy into other disciplines, most especially into science? Because, in the Philippines, let me just remind the global participants, in our country, in our education, science is said to be being delivered into four components. We have physics, chemistry, biology, and earth science. So before, we have a curriculum of basic education curriculum, but right now we have this K to 12 curriculum, wherein there is actually spiral progression in the curriculum, wherein the students should learn the different components of science. Okay, now philosophy and teacher professionalism. All professions have philosophical underpinnings, and that's true. All right. So I am now telling all of you that philosophy is not only for science, it can also be uh, relate into other field of endeavor. Educational philosophy is one important aspect of teachers' professional knowledge. So all of us teachers must have this educational philosophy. And I think that's the reason why uh, the first presenter expounded the idea that all teachers must know their educational philosophies. So recognizing our generation today, we know we have, the generation of the silent. Look at the years. So 1922 to 1945. So we have silent generation. We have the boomer, 1946 to 1964. Gen X or Generation X, we have 1965 to 1980, and then Gen Y, all right? So 1981 to 2000. And all of these generations have different uh, behaviors. So they have different work ethics, leadership style, interactive style, communications, rewards, messages that motivate, and work and family. So the question now is, how can we now use philosophy in order to influence our generation today? So we will now revisit the traditional schools of philosophy. So let's have this walkthrough. We know that these are already, old or traditional, but let us try to reflect. Let's contemplate whether these traditional school of philosophies are still applicable in our uh, generation. Okay, the first one is idealism. So let's get the keyword, and that is idea, meaning to say it asserts that because the physical world is always changing, ideas are the only reliable form of reality. Okay, so that is the thinking of this what we call idealist, meaning to say the world is changing, so therefore the ideas are the constant or reliable form of reality. Example: optimism, skepticism, cogito ergo sum, and transcendental idealism. These are all examples of idealism. So one statement of an idealist is the belief of people who think they can save the world. So if you try to reflect on that, can people really save the world? All right. So we are teaching our students to think that they can solve the world, but we know that it takes a lot of uh, effort in order to save the world, right? We need a lot of people to solve the problems of the world, okay? But these are ideas, okay? And we know that our students today, that they have a lot of ideas in their mind. So they think that, example, they love to play, a lot of games in the Philippines. They play Mobile Legends, right? So there is already addiction, all right? For them, when they play, it gives satisfaction and fulfillment, All right, but in reality, reality check, there are things that are being neglected, right? So we need to help our students to realize what is said to be important, okay, and that is to value time, right? So, but for idealist people, their focus is just on ideas, because ideas are said to be reliable form of reality. Okay? So optimism, meaning you are always positive, right? Skepticism, you try to critique now the knowledge uh, that you gain or that you read in the book. All right. So are we now saying that a science learner should not be an idealist? No. Okay. We want also our students. We can adopt this principle, okay, that there are some ideas that are said to be reality, okay. So look at this one. So our mind is so powerful, right? It can create a lot of images. Look at this one. Try to focus on these images, and you can see different image. The mind is really complex. It creates a lot of imagination. And that is why being a science teacher is not easy, right? Every student or every learner has their own philosophies. So therefore, what is our stand as a science teacher? So, and that's the reason why we want to apply strong traditional philosophies in order to debunk some ideas that are not part of reality, right? So another picture. So you can also see, different images, no? And this is part of the Gestalt psychology, if you know that. Another one, what is your interpretation with this picture? You can think that the dog is very bad, right? But when you go to other angle, you will realize that the dog is just saving the ship from being drawn, right? So meaning to say, we need to check the other angles of the situation, and that is philosophy, right? Meaning to say, we help our science learners to question, okay, to question everything in their surrounding. They are not just following or approving things, but they should validate whether this information are really true. So part of idealism, we have absolute idealism. So this philosophy of absolute idealism began with George Wilhelm Friedrich Hegel. It suggests that thought and being must have their own sense of identity for the mind to interact with the world. Okay, people relate to the world not because it is different from the mind, but because it is of the same substance. Okay, so this is what we call absolute idealism. Another one, actual idealism. So posits the idea that actually perceiving the world around you is what truly defines reality. So meaning to say, what you perceive, that's already the reality. And there are science learners. What they observe, they will already conclude that that is the reality. So they will not perform this what we call experimentation. They will not use scientific method in order to validate the information or the perception. So this is actual idealism. Another one, biological idealism by Arthur Schopenhauer is behind the philosophy of biological idealism. It suggests that what is useful for an organism, okay, to believe might differ greatly from the way things actually are. Okay? In other words, the way organisms understand their environment is what is most important to living things. Okay? So if that is important for you, you will now consider it as your reality. There is also monistic idealism. So monistic idealism asserts that matter is not the makeup of everything that exists, but rather everything that exists that's so solely within and because of consciousness. Highlight the word consciousness. So monistic idealism concentrates that everything is just part of our consciousness. All the things that we see, remember in chemistry, we know that the central focus of chemistry is matter, right? But here, in terms of idealism, the focus is consciousness. So, in other words, this approach to idealism posits that the only objective thing in the universe is consciousness. Objective idealism, uh, according here, that individual is the one who is perceiving things. This form of idealism accepts that actual things exist, okay? Which is a concept of realism, which is the opposite of idealism, okay? However, it rejects that the mind is a result of material objects or the physical world, okay? So, example, we can actually integrate the 5 E's, right? One of the best method that we can integrate when we are teaching science, right? So example, I can recognize that according to cell theory, all organisms are composed of cells and cells carry on similar functions. So it can be that our students will have already that idea that cell theory is correct. So, but of course, what is now the role of a science teacher? So we need to, of course, appreciate that our students have the idea that partly cell theory can be true because it has a lot of basis. We are not debunking any theory because they have their basis and they are just waiting to be universally accepted. Okay? So again, idealism has also the basis, and we cannot set aside idealism. So can idealism still be relevant now in science education? Yes. It could be we can encounter a lot of science learners who have plenty of ideas. So our role now as a science teacher is to help this learner to arrange their ideas. Okay? All right, scientific method. Okay, so of course we know the scientific method. It starts with question and then do background research. Okay, until such time, you will recognize that scientific method is very useful in making sure that the ideas of our students can be validated through experimentation. We are teaching them not to conclude, okay, right away. All right. So there are traditional philosophies that we know. We have the realism from the word itself. We're talking of reality. All right. So where can we now integrate realism? Okay. By performing experimentation. Okay. Now the relevance to science education. Okay. So we have a lot of topics in science wherein we can show reality with our students. Okay, example, neutral objects have balance of charge, equal numbers of protons and electrons. So we can use PET interactive simulations. I'm actually using a lot of uh, laboratory softwares or applications because right now, I mentioned a while ago that we are in pandemic, so we need to use a lot of softwares in order to improve our science teaching. Okay, so another traditional schools of philosophy is pragmatism, rejects the idea of absolute unchanging truth. So what works? Okay, meaning to say the summary of pragmatism is we are not only letting our students to remain the idea in their mind, but they should perform. All right, they need to perform, and that is pragmatism. right? It's more of the practicality of learning. How can they use that learning into, making inventions? Uh, in our country right now, we're trying to improve robotics, wherein we try to let our learners to be creative and innovative, and that is pragmatism, right? So relevance to science education, knowledge that is actually implemented is much more likely to be acquired from learning by doing. And we know that because that idea came from John Dewey. Okay? So another philosophy is existentialism. Okay? So individuals create their own realities. Okay? So existentialists believe that every individual is unique. Okay? So every time we teach different scientific concepts, let us be reminded on the idea that our learners have individual differences. They are diverse in terms of their thinking. They have different philosophies. So how can we now help them to ponder scientific concepts? So we apply now existentialism. So there are a lot of informations about existentialism, but what is now the relevance into science education? In the Philippines, we have 11,460 scientists and engineers. So what I'm pointing out is that we need to encourage our science learners to be future scientists of this country. All right. So, why is it that many students do not like science? Why is it that many students like other, field of endeavor? They don't like science. So, meaning to say, some of us, lacks in terms of encouragement with our students. So we need to motivate them. We need to help them realize the value of science and technology. All right. So what is now the lesson? Be positive, role model, make it fun, connect it to everyday life, give them opportunities, and bring it to life. Okay. So that is the message. Okay. So we need to help our learners to exist in the society. Now, there are basic philosophies of education. We have perennialism, essentialism, behaviorism, progressivism, existentialism, constructivism, and postmodernism. No, all of these were mentioned already, so I will just give summary. So perennialism is concern of the that nature is said to be constant, and it is rooted in idealism and realism. Okay, so in perennialism, focuses on the education should be the ideas that have lasted ever over centuries. They believe that ideas are as relevant and meaningful today as when they were written. Okay, so that is the highlights of perennialism, learning without end. Okay, and what is now the lesson in perennialism? What can be the relevance of perennialism into science education? Sustainable development. So don't forget, my dear co-educator in science, we need to integrate in the curriculum the word sustainable or sustainability, right? So meaning to say, we need to teach our students to value what they have, and they should also think of the next generation. So example, they will consume this natural resources. So when we consume these natural resources, we must also think of the other generation. All right. So uh, as a researcher, also I conducted this research study showing the seeds of environmental care. It's all about regreening the municipality of Bambantarlac. Uh, we educate our learners to value trees, so they perform seed germination, uh, different techniques like baggy method. They perform seed collection, and they created, nursery wherein they place a lot of seedlings. So meaning to say, this particular research project help our learners to develop their thinking about sustainable development. Another one is essentialism. Okay? So the focus of essentialism, critical role of knowledge and skills exists that all people must possess. Okay? Knowledge and skills. So meaning to say they need to perform. Okay? They need to focus on the things that are said to be essential. Okay, what are the practical things in science education that we can ask our students to perform in the class? Okay, and that's the reason in the Philippines we have this most essential learning competency. We are focusing on the essential learning competencies. Especially we are in the midst of this pandemic. Relevance to science education. So how can we relate now the philosophy of essentialism? So we need to provide worksheets or hands-on projects. Okay, so that is the focus of essentialism. Behaviorism, okay, theory of animal and human learning that only focuses on objectively observable behavior. So we know in the principle of behaviorism, there is the principle of classical conditioning and operant, the principle of reward and punishment, the principle of how we can condition our science learners inside our classroom. Okay, so this is what I'm talking about. We also have cognitivism, meaning to say when there is an input of information to the mind of our students, they need to process the information. They should not believe it right away. They should not conclude right away. They need to process the information. And that is what science education is aiming. All right. So this is a picture of how complex our mind is, right? Especially in the cerebrum, wherein all thinking is said to be happening. All right. So there are neurons involved. Okay. So I think you're familiar with the information processing model. So we have the sensory memory, working memory, and long-term memory. And that is what we aim, that our students must have this what we call long-term memory. So we have explicit and implicit long-term memory. Another one is progressivism. From the word itself, progress. Of course, we want our science learners to progress in terms of their scientific literacy. Okay, and that is why we want our science learners to have this real world problem solving. Okay, so these are the relevant ways in order to help our students to apply this what we call progressivism. Okay, another one is constructivism. Okay, the main point of constructivism is that knowledge and meaning come from our own experiences. So we let our learners to construct knowledge by themselves. There is no spoon feeding. Okay, so of course we can use in science education the 5 E's: engage, explore, explain, elaborate, and evaluate. So in the Bloom's taxonomy for thinking, we want our learners to reach that pinnacle, and that is evaluation. That our learners should evaluate, okay? There has to be judgment, okay, for our learners. Okay, they can perform, very good judgment, okay, and they can evaluate, okay, through research, okay. So this is a picture showing to us how we can promote constructivism by having hands-on activities or experimentation. Science investigatory projects can be also a gateway for constructivism. All right. So standards and essential knowledge. So there are many philosophies that we can actually integrate in education. But of course, we need to examine ourselves. What philosophy do I have in terms of teaching science learners? Okay. So let's go back now to the question. Is philosophy relevant to science education? The answer is yes. Okay, and I would like to end with this quotation: education without philosophy is blind, and philosophy without education is invalid. Thank you so much, and have a nice evening to all of us.
All right, so thank you so much once again. That was Sir Michael R. Maglake, our second resource speaker for today. Okay, so congratulations, Sir Mark and Sir Michael, for giving us a meaningful presentation today regarding pedagogical analysis, science, and mathematics education. So, like, once again, thank you so much for sharing your knowledge with us. And again, no doubt that our viewers learn so much from the techniques, interesting stories, beautiful insights, and so much takeaways from YouTube. Okay, so all
Thank you
right.
so
So
much,
once
sir.
again, let's all give a virtual round of applause to Sir Michael and Sir Mark. Okay, thank you so much, sir. Due to some time constraints, we regret that we are not going to proceed on our quiz and question and answer activity for today. So, nevertheless, I would like to thank each and every one of you for attending our sessions for today. Hopefully, you've learned something new and something interesting today. Please leave a review or recommend our page if you learned something wonderful on our discussion for today. So, like once more, do not forget to collect your e-certificate and give a check-in with IGP. Please spread the information with your friends, and we hope to see you all again on our next webinar. So as of this time, our website is not working properly. We will give our webinar code by tomorrow. And for now, please collect the certification link to be sent after this webinar. So thank you so much for staying with us till the end. Again, I am Sir Jason S. Yumang saying thank you, be safe, and stay happy always. Thank you.